Hello everyone, thanks for having me. This is my first time in eCream, so I'm pretty excited. So, my name is Maurizio Mangione, but a lot of people know me on the internet as Granze. I'm a Google developer expert for web technologies. I'm a Microsoft MVP, and I founded Milano.js. That is the largest JavaScript community in Italy. And I moved from Italy to Amsterdam last January to join The Zone. The Zone is a company that does live streaming of sport. Basically, it's like Netflix, but for live streaming sports. And I joined the company as a developer advocate, the first one of the company. So, the topic of today is PWA because everyone loves PWA. So everyone is excited about progressive web apps, service worker, cache API, push notification, and all this kind of stuff. And I think that every day on Medium or on dev.to, a post about progressive web app comes out, right? But most of the posts just talk about the possibility of progressive web app, but sometimes they don't explain how to use that in production nowadays. So, exactly, what is a PWA? So, it's not a short answer actually, because progressive web apps means a lot of things. So, under the PWA umbrella, we have some of the new API of the web platform, like the cache API or like service worker or background sync or a lot another stuff. But for me, progressive web apps are a way to really give the user a nice experience. So it will enhance your website with cool features. And I know that most of you already have heard about this feature, so push notification is not a new thing for anyone, but it is on the web. So the thing is that the exciting part here are not the feature itself, but the thing that you can use this feature on the web, because we're used to know this feature for mobile apps. So this is really what changed. So I started, I think, like 3 years ago, talking about progressive web apps. So I did my first talk 3 years ago, and yes, progressive web apps were a thing also 3 years ago. Of course, you know, it was hard at the time because of the browser support, but still, 3 years ago, I was sure that it was a good idea to start using the cache API along with the service worker for, try to enhance the performance of the website. Because the cool things of progressive web apps is the progressive world. So you can add some feature to your existing application, and the user with a modern browser that supports this feature will leverage the power of this feature to have a better experience. And the user that doesn't support this kind of feature will have the same experience as before. So that's cool. My second talk I gave a couple of years ago was all focused about service worker, because service worker are a bit tricky, especially if you have to debug them or work with them, so it's not that easy at the beginning. And the last talk I gave was LDD for progressive web apps. LDD stands for Lighthouse-Driven Development, so a sort of TDD, but using Lighthouse. So the concept was to start from a classic single-page application, run Lighthouse, the tool inside the Chrome DevTools, and run through the PWA test. They, of course, will fail at the beginning. And then, with a session of live coding, I went through the solving of the problem, so implementing all the steps to pass all the tests. And the talk of today actually is about how to use today progressive web apps, the feature of progressive web app in your app with easy. So, but why I'm talking so much about PWA? So, first of all, because I love standards. So, we all love frameworks and libraries. We all love Angular, React, whatever. But sometimes we lose focus from the really important things that are the standards, because all the frameworks on the library are based on these standards. And nowadays we have really interesting standards like web components, like all the stuff we have in progressive web apps. So that's what is the first why. And the second answer is because progressive web apps are the most exciting thing that happened to the web since Ajax, for me at least. So I remember in 2005 when Ajax came out, and it was a revolution, right? So we still work in this way many years after this Ajax came out. And for me, Service Worker and the Cache API are on the same page, are maybe or less the same thing. So I'm not going to talk about the vanilla implementation of this API, but we will implement this feature through Workbox. So Workbox.js is a small library made by Google, and it's just a small abstraction on top on the Service Worker and Cache API. And I really like small abstraction because I don't like, bloated framework and libraries. And I like Workbox because it's really minimal. So actually, the API from Service Worker and Cache API is really neat. It's really clean, is really minimal by itself. So why we should use a library on top of it? Well, because it will help us not to reinvent the wheel every time, and we will see how. So actually there's a lot of websites and apps that use Workbox since the last year, so Wired, Tinder, Pinterest, and so on. So it's already a well-established library, so is not, kind of bleeding edge library that, yeah, it's cool, but I will never use it in production. So the description on the Workbox.js website is JavaScript libraries for adding offline support to web apps. That's a kind of high-level description of the library. So what does this mean? So it means that it will help us to use the Cache API and the Service Worker together to achieve a lot of cool things. And before we go further in the topic, bear in mind that the Cache API has nothing to do with the browser cache we know and love. Well, no one loves the browser cache, actually. So the Cache API is really different. So how is different? So we have our beautiful client and we have our server. So every time we do a request to the server, even though we have cached file, what happens is that the time trip from the client to the server could take a lot of time. Maybe because the server is overloaded, maybe because I have a crappy connection on my mobile. There are many reasons why the connection and the time trip will take a lot of time. So the thing is that the assets we have cached on our client should be validated with the server. So even though I'm asking for resources I already have on my client, I need to wait for the server. And this sucks, actually. because the resources are already there, but I need to wait. So how is different the cache API? So the cool thing is that the service worker will intercept all the call we do, and we can decide what to do with these requests. So in some cases, we can decide not to touch the server at all and just grab our assets from the cache. That is a local cache. And this is pretty cool, because this feature is the one that allows us to have an instant loading of the page, mostly instant, and offline support. That's the trick, basically, because we don't need to go through the server if you don't want. So it's all about caching. And with the service worker and the cache API, we generally use two types of caching: pre-caching and runtime caching. And they are different. So pre-caching is mostly for resources that doesn't change. That's the change just when we release a new feature of the website. So we can think about some CSS, maybe the main CSS, the common CSS of the website, some JavaScript that is used along to the website, or the app shell. So we all hate to see a white page with a loading spinner, because we know that probably the page isn't loading at all, because we know that it's just an animated GIF. So this means nothing to us. But if you give to the user at least the skeleton of the page with the loader, first of all, it will be faster. The performance perceived by the user will be better, of course, so the experience of the user will be better. And our website, our application will be fast, so that's a good idea. And pre-caching is just for these things. So Workbox help us with the pre-caching with three tools that do the same thing, actually, but in different way. So, of course, we all love Webpack, and if we start a project today, we probably will use Webpack. But the thing is, maybe we want to add some PWA feature to existing projects that are already in production. So maybe the project uses Gulp, and it's totally fine. We are not going to refactor the application to, passing from Gulp to Webpack, because maybe it makes no sense, or maybe we don't have time for that. So Workbox allows us to create a service worker directly from Gulp, and this is really useful. So Workbox exposes a global object, Workbox, that has many functions in it. Generate service worker allows us, given a folder and some type of file we specify in a pattern, in a glob pattern in this case, to be included in the service worker. So first of all, why should I use this instead of adding my files manually? Well, the first reason is because if you want to add your files manually, you have to add these files one by one, because you can't use globbing or regex. But you can in Workbox, and that's really useful. But there is more, and we will see what in a minute. But if you have specific needs, so you want to build part of your service worker by yourself, maybe because you have some logic for push notification, you can do that. And you just need to add in your service worker an inject point, so Workbox knows where to put your pre-caching stuff. And it is super easy. You just need to use workbox pre-caching route, and put an empty array in the function, and workbox will fill the array. In this case, we need to specify, of course, not only the directive, the director we are going to use, but the service worker file, because of course we need to tell workbox where is the service worker. And what workbox will do is adding something like this. So, apart from the name of the resources we are going to cache, he will put also an hash like this, and it will be easier for workbox to find out if the resources is changed or not when we build the project. So, there is another way to use workbox, and is in the CLI. So we want just to add a one line to our package.json to do the build. This is perfectly fine. We just need to create a workbox-config.js file to specify the same thing we specified in gulp, actually. And then in our script object, we just need to add our workbox generate SW script along with the other script we use for the build. So it's really nice and easy. So the Webpack plugin is even easier, because we just need to add a Webpack and invoke the generate service worker function and tell workbox the destination of our service worker. And that's it. But last week, they changed a lot of things in this build tool, so perfectly in time with my talk. Actually, there are some breaking changes, but nothing really fancy. It's just about some configuration we use with the build. So if you want to start a new project now, I suggest you to take a look at the V5 alpha version of Workbox, so at least you will, be aware on what's going on. So runtime caching is really different and is a bit more complicated. So let's take 3 caching strategies. So with Service Worker, we implement caching strategies because we have different needs. And let's take these 3 that are 3 really common caching strategies. So cache then network then cache, and cache and network race. So in the first one, this is vanilla, the vanilla code. What I'm doing here, so self is the global object of the service worker, and as you can see, the vanilla API is really nice because it's based on event and promises. So if you're familiar, and I think you are, with promises and events, you're good to go. And this example actually is really simple because we are listening to the fetch event, that is the call we want to do to the server, and we define what your response is. So we are looking for a match between the resources I requested to the server and what I have in my cache. If they match, I will return these resources. So I will have the offline support, and I will have also instant loading. Otherwise, I will do a fetch function in this case, and I will just forward the request. Network and cache is the opposite. So I'm going to get my request, and I forward directly to the server. In case of an error that I will grab with cache, I can check for a match in my cache and return the files if they are there, of course. If you look at this one, is a bit more complicated. So in this case, we're going to ask the same resources to the cache and to the server. And the first one that will fulfill will respond first, and we will take that answer. But we can't use promise.raise, because if one of them will be rejected, all the promises will be rejected. That's not good. So we need to do something like this. And okay, it's not rocket science, but then it's not something I want to write all the time, right? But it can be even worse. For example, if I'm going to implement a staleware revalidate strategy, so it's just a fancy name, but it's for a strategy that is really commonly used. And it works like that, more or less. So my page asks for my resources to the service worker. The service worker will ask the cache, do you have these resources? Yes or no. But in the meantime, I will go also to the network, because I want to give the user something as soon as possible. So I will respond with the cached file to get an instant loading and offline support as well. But if I'm not offline, I will go to the network, grab the new stuff if something is there, and update my cache. This is because the next time my user will land on my website or in my app, he will get the new stuff. But I can do more, because once my cache is updated and I have the payload from the network, I can decide what to do with these things, because I have the new resources, they are there. So I can wait till the next time to provide the user the new stuff, but maybe it's important to notify the user that new stuff is available. So in this case, what I can do is just pop up a toaster, a notification, something that tells the user, hey, there are updates on this web page. Click here, and I will refresh the page with the new content. I think you already saw that in Gmail and in other apps that use this kind of thing. So this is really useful, but implementing this strategy is not that easy, because there are a lot of things involved in this strategy. Not just the strategy, but also the notification to the user and what I do with the old cache. The power of Cache API is that you have total control over it, but you have to deal with all the aspects of the cache by yourself. This means that every new cache will have a new name, and you have to delete the oldest one, also because all the devices have a certain amount of capacity. So you want to delete the old stuff the user don't need anymore. And you have to do this manually, if you don't use Workbox, of course. So how staleware revalidate looks in Workbox? It looks like this. So I just need to import Workbox and then leverage the staleware revalidate method on my strategies object, and that's it. That's super easy, right? But there is more. What if I need more? What if I need to, specify something because the default behavior doesn't match, my needs? So you can specify a lot of things. So we talked earlier about how the network, the problem the network has, so the fact that we can wait for 10, 20 seconds for a request. So if we use the network first strategy, so we will ask the network first for the file, and then we will fall back on the cache API, there is a problem, because if the network is low, if the server is not responding, we already have the file in the cache, but we want to query the server first, and we should just wait. We need to wait for, I don't know, 10 seconds, 20 seconds. Maybe the server will be going timeout. Who knows? But I can specify how many seconds I want to wait before giving the user the files from the cache. Just in one line. This is really, really handy. And also, this is not a thing you want to implement by yourself every time. But we have more options. Also, we don't want to use just one cache for all the application. Maybe we want to split our assets in different cache. And we can specify that for the network first strategy, I'm going to use a cache name named entries. But there is even more. I can use a lot of Workbox plugin, like this one is really interesting, the expiration plugin. I can decide when my assets should be expired. And it's nice and easy. Okay, everyone loves cats. We just look at a lot of code, so just a second. And here we go. We are ready for the next topic. That is routing. Routing is another super, super cool feature of Workbox that works very well with the casing strategy. So we can put the two things together, and we will end up with something like this that maybe reminds you Express.js. So you have a function, you define a route, and when this route will be hit, something will happen. So I'm saying here that if I go to granze.net, that is my website, /about, I will use a network first strategy for this page. Because, I don't know, maybe I change my picture on the website every day, so I don't want the cached one. So I can specify this, and this is really useful. Another super cool thing is that I can use regexp. So I can use regular expression to decide which path will be involved. And in this case, I will say, okay, I will use state-wide revalidate for all the JavaScript and CSS. So it's not just about a page, but we can specify which kind of asset we want to cache. This works really well with images, because sometimes we know that images should be deprecated after a while, so we can say, okay, all the images on my website should be used a cache first strategy, because I want the image to load really fast, but they need to expire in 30 days. And all this stuff, if you want to implement all this stuff by yourself, is a lot of code. So for the dog lovers, so I'm a cat person, but yeah, I know people love dogs as well. So background sync, I think, is the most tricky part of Service Worker, and also the browser support is not great at the moment, but they worth looking into it because they're really, really interesting. So Workbox provide also a plugin for background sync. So what we have to do when we use the background sync is specify a name for a queue, the queue of the files that are, in the purgatory waiting for the network. So a common use for background sync is sending forms. For example, I think it's happened to you a lot of time that you're on a smartphone filling up a form that is a horrible, horrible experience on the smartphone, and then you send, and when you push send, you lose your connection, and you get a blank page. That's horrible, right? But with background sync, you can handle this. Take this payload and save it for later. And when the network will be available again, the background sync will send the payload to the server. And eventually, you can notify the user that that's just happened. So that's really, really cool. So this is a tip because I really spent a lot of time trying to debug background sync, because I thought it was I just needed to turn off the network to try the background sync locally. But if you don't shut down your server, it will not work, because the service worker will still see your server, so your local server, so it's not gonna work. So you need to shut down your server and then open your Chrome Dev tool, and there is a sync property, and you can set the name of your queue and try your background sync. Nice and easy. So last thing for today is Workbox window. That is a pretty new thing that Workbox implemented. So service worker are living in another thread. So they are not living in the main thread of JavaScript. Even though JavaScript is single thread, service worker are in another thread, and they have some differences from the main thread. For example, they can't touch the DOM. So I can't manipulate the DOM from the service worker. So if I need to manipulate the DOM, for example, show a notification to the user, what I need to do is notify the other threads that something happened. And there are, you can do it with post messages, with many approaches, but Workbox windows give us some event to listen for that we can use directly in our client. Is really handy, because I don't need to pass the messages by myself, but I need just to attach an event listener in my client, and that's it. And there are various events I can listen for. So, as I said, browser support is not great for background sync, but is kind of good for the other stuff. So service worker and cache API are implemented almost everywhere, even in Safari. But Apple set some restriction on the size of the amount of data you can cache, and they will eventually delete your cache sometime soon. I don't know, we don't know. But just keep in mind this kind of thing, but it's not a reason not to use progressive web apps today. So the wrap is Workbox is cool, but of course we don't use technologies, framework, libraries just because they are cool. We want to use something that is really helpful for us, and Workbox.js actually is really a good tool if you are working with PWA. So, and everyone knows that good ideas plus good tools together allow us to create great things. No, that's bad. That was the good part of the presentation. It's a flying drone cat. Here we go. Thank you very much.